Good day, everyone. In today's video, I will be discussing about basic integration, specifically the indefinite integral. So, let's start. So, let me first put the formulas in order for us to solve the uh, functions using integration. Of course, in this video, the learning objectives is to know the techniques and fundamentals of integrations. So, this is just a basic integration. I will discuss it more simpler so that you can understand what I'm talking about in here. So, let's just say we have the integral of a dx. Now, our a here is constant. So we can put it outside. Then what's left inside is dx. So in integration, if you have this is just a, copy the constant, x plus c. Another one. What about ax dx? So if you have this function, this is constant, put it outside, and then our x here, let's copy first. And then if we integrate this is just x. So we know that it has an exponent of 1. So in integration, if we integrate this, we just add 1 and then its exponent, which is 1 plus 1 plus c. So this is actually a power formula. Now let me give another one. This is a power formula. So again, just take out the x, and then what's left is x raised to n dx. And then we have a. So if we integrate this is just gonna be x n plus 1 over n plus 1 plus c. So this is actually a power formula. Power formula. Now let me give you an example. So let's say example number 1. So what if we are given 6x squared dx? So in this case, let's just, our 6 here, let's put it outside. So what's left inside is x squared dx. So this is just 6. So the integral of x squared is x 2 plus 1 raised to 2 plus 1 over 2 plus 1. So this is power formula, right? Plus c. Don't forget to, if we integrate functions, don't forget to add plus c. Now simplifying, we have 6 x cubed over 3 plus c. And we can simplify this. So the final answer is 2x cubed plus c. So this is our final answer. Now, let me give you another one example. So let's say we have 2x squared plus 3x dx. So by inspection, we know that this is just a power formula. So what we need to do is first take out the constant, then multiply by the integral. So we know that this is just x cubed. So 2 plus 1 will be 3 over 3. plus, so take out the constant, and then x, so we know that we have 1 in here, so this is just x squared over 2 plus c. So we can simplify this, so this is 2/3 x cubed plus 3/2 x squared plus c. So this is our final answer. So this is actually integrating algebraic functions. Now let's go to integrating logarithmic functions. Just for a sec. So what about if you are given a function like this? So 5 over x dx, the integral, sorry. So what will you do? So let's recall that the derivative of ln x with respect to dx, so this is just 1 over x, right? So this is just same as this. So let's integrate this. So in integration, if we have a raised to x dx over x, I mean dx, this is just a ln of x plus c plus c. So this is just the reciprocal of the ln x. Now let's solve the problem. So this is just 5 ln x plus c, right? Since let me write it again, sorry. A over x dx is equals to a ln x plus c. So this is correct. Now let me give you another problem. So this is 1 and 2. So what if we have 4x squared plus x minus 7 over x dx? So how to integrate this? So first, what we have learned is take the constant out, then copy the constant, so and then this is just a power formula, so x cubed over 3, then we know that we have 1 in here, so this is just x squared over 2, then this is just ln, right? So 7 ln of x plus c. So this is our answer. Now let's just how about if, so this is for logarithmic functions. So what if we are given let me just erase this. So what if we are given a function like this, e raised to 5x dx? So how to integrate this? Okay, so let me give you a formula. So number 1, e raised to bx, our b here is constant, so in order to integrate this, we just copy this. Let me change my marker. Just copy this. So this is just gonna be e raised to bx, then over b plus c. You see what I did there? So I just copy it, then the constant. And another, what if a raised to x dx is equals, this is just equals to, copy, a raised to x, our a here is constant, over ln of a plus c. So now, this is for exponential functions. Now let me give you an example. Or let's say we solve this. So as our formula suggests, to integrate this is just e 5x, just copy, and then it's constant plus c. So this is our answer. How about if we are given a problem? So this is example number 1, example number 2. So what if we are given a problem like the integral of 5 raised to x dx? So this is it, right? We can use this. Now, this is just, so 5x over ln of 5 plus c. So now, this is our answer. So this is just a basic integration on how to integrate algebraic, logarithmic, and exponential. So how about trigonometric? So how about trigo? Now, number 1, so what if we have the integral of sine 4x dx? So, this is just negative cosine, copy the angle 4x, then over 4 plus c. How about if we have cosine 3x dx? So the integral of cosine is just sine, right? So this is just sine 3x over 3 plus c. Since the derivative of sine is negative cosine. So how about if we have the integral of secant squared 7x dx? So this is just tangent, since the derivative of tangent is secant squared. So this is just the opposite. 7x over 7 plus c. So how about cosecant squared? The integral of cosecant squared 2x dx. So this is just negative cotangent 2x over 2 plus c. Now how about if we have the integral of secant 3x tangent 3x dx? So this is just secant 3x, since the derivative of secant 3x is just secant 3x tangent 3x over 3 plus c. Now how about if we have cosecant x, let's say 4x, cotangent 4x dx? So this is just negative cosecant 4x over 4 plus c. So this is how you integrate trigonometric functions. Now let me give you an example. How about if we have a problem like the integral of sine 2x minus cosine 7x plus secant squared 8x. So now that we know how to integrate trigonometric functions, we can easily solve this. So the integral of sine is just what? Negative cosine 2x over 2, a constant. Next, we have the integral of cosine is just sine 7x over 7. Now, what is the integral of secant squared? So this is just tangent 8x over 8 plus c. Now, this is our final answer. So now, let's go to a technique on how to integrate. So there are many techniques on how to integrate, but let's just discuss first what is U-substitution. So let me give you some of the formulas, general integration formulas. So this is for U-substitution. So let's say u raised to n du. So we know that this is just a power formula, right? So this is just u n plus 1 over n plus 1 plus c, right? Then next we have, how about if we have du over u? So this is just ln u plus c. Now how about if we have the integral of the exponent raised to u du? This is just e u plus c. Now how about if we have a, which is constant, raised to u du? This is just a raised to u over ln a plus c, right? So let me give you an example in integrating functions using U-substitution. So let me just erase this first. Now how about if we are given the integral of x cubed plus 3 x squared dx? So how are we going to integrate this? So in order to determine our u is just inside, some are inside in the parentheses, some are exponent, and some are inside the square root. So in this case, we know that this is our u, right? So let me try. So our u is x cubed plus 3. And our du is 3x squared dx, right? The derivative. Now, let me what's missing here is 3, right? Now, if we put 3 in here, we need to reciprocal it in order to be balanced. So let me rewrite it clearly. So this is just 1/3 the integral of x cubed plus 3 3x squared dx. Now we know that our u is here and our du is here. So now let me rewrite it in here. So 1/3 the integral of u and then our du. Now we can integrate this. So in our previous in the previous the formula that I write, so this is just a power formula. So this is just u squared over 2 plus c, right? Now we can simplify 1/6 u squared plus c. So in U-substitution, we need to revert it back to its original value. So this is just going to be 1/6 x cubed plus 3. Our u is x cubed plus 3 squared, since we have a squared here, plus c. So this is our answer. Now let me give you another problem or another example. How about if we are given the integral of 1 plus square root of x over square root of x dx. So how to integrate this? So let me write my u as 1 plus square root of x. We can rewrite this as 1 plus x raised to 1/2, right? Now, if we integrate this, differentiate, so this is just constant, so it is just 0. How about this? So this is just 1/2 x negative 1/2 dx. Or we can rewrite this as 2 square root of x. Since it is negative, we can put it in our denominator, dx. Now, let's, so what's missing here? What's missing is 2, right? Now, if we put 2 in here, we will put its reciprocal. So, this is 1/2. So, its reciprocal is just 2. Now, let's rewrite this in terms of u. So 1 plus square root of x is our u, and this is our du, right? This is our du here. So this is just 2. So as you can see, this is just another power formula. So u squared over 2 plus c. So we can cancel this, right? Then what's left is u squared plus c. Now we revert back to its original value. Now this is just 1 plus square root of x squared plus c. Now this is our answer. Now this is for U-substitution. Now how about another technique called integration by parts? So let me teach you on how to integrate by parts. So recall the product rule in differentiation. So let me write this. So the derivative of uv is just u dv plus v du, right? So first, so this is just product rule, right? Now, how about if we integrate? So u dv, the integral of u dv, so I just transfer it, and then the integral of the derivative of uv minus the integral of v du. So to simplify, this is just u dv is equals to uv, since it will cancel out, this will cancel out, minus the integral of v du. So this is actually our formula when solving integration by parts. Now let me give you an example. Let me rewrite this. So u dv is equals to uv minus v du, the integral of v du. So how about we have a problem like this, the integral of ln x dx. So how do we integrate this, and how to determine our u and our v or dv? Okay, so let me try. How about if our u here is ln x? What is our du? It's just 1 over x dx. Or this is just dx over x. It is just the same, right? And our dv here is, how about if we choose dx? How about our v? So if we integrate this is just x, right? Now let us use this. So our u is ln x and our v is x. So this is just x ln x minus the integral of v, which is x. Then our du is just dx over x, right? So by inspection, we can cancel this and this. So what's left is x ln x minus the integral of dx, right? Now we can integrate this directly. So this is just x, right? And don't forget to add plus c. So this is our final answer. It's easy, right? If we know the formula. And of course, if we know how to locate where or what is our u and what is our dv or v, right? Now let me give you another example. How about if we are given let's use trigonometric functions. How about if we have x sine x dx? So how do we integrate this? So this is our u, and this is our dv. So u is equals to x, du is just equal to dx, right? Our dv is sine x dx. Our v, if we integrate this, this is just negative cosine x. Now let's uh, integrate this using integration by parts. So uv, right? So our u is x, our v is negative cosine x. So let me write this as negative x cosine x. So this is our uv minus the integral of v, then du, right? So this is just negative cosine x dx. Now integrate. This is just negative x cosine x. So since this is both negative, we can this is positive, right? And let me rewrite first dx. So let me integrate negative x cosine x plus, what is the derivative of cosine x? Very good. It is just sine x plus c, right? So this is our final answer. So I guess that's it for today's video. I hope that you have learned something. So let me recap what we have learned. So first we discussed about basic integration, use with using indefinite integral, right? Or rather with definite and indefinite integral, algebraic functions, logarithmic functions, we have the exponential functions and trigonometric functions. Then we also discuss the U-substitution and the integration by parts. So I think that's all. So thank you for watching.